So good morning, peeps. This is a toughie, okay, because I've pinpointed a couple of key instances, right, where two things are happening. Now this, for me, it's common sense, okay? My common sense is obviously different than most people's common sense. The speed of light, I call it absolute, okay? There's no 299,792 kilometers per second for me, right? And for a lot of reasons, right? I've been talking about this all over the place, right? Instagram, on Facebook, on TikTok, on YouTube. I am in chats everywhere, all right? So what I did on Facebook, my last one, instead of me doing all the work, what I said to the people who were reading and watching, I said, right, here we go. You've got a 3mm bulb, right? If you have a 3mm bulb and you're going to use that as your sun in this 2-scale diagram, what is the distance between that bulb and planet Earth, and what would Earth's diameter be? Okay, so that straight away gives somebody something to do to work out, because I'm sick of talking about this stuff to people who wouldn't even be able to work that out. Because if somebody can't even work that out, what I'm talking about is way over their heads anyway, right? It took over 24 hours, right? But the one guy who I was talking to originally was the one that came up with the answer, all right? Now, if you've got a 3mm bulb and you're using it as in a 2-scale diagram, right, of Earth, Sun, and the distance in between, you've got a 3mm bulb. To find the distance between that bulb and Earth, right, to scale, you've got to multiply it by 108, because there are 108 suns in between Earth and the Sun. So what we do is the 3mm bulb for the Sun multiplied by 108 equals 32.4 centimeters. So the distance between a 3mm bulb, if it were the Sun, and Earth would be 32.4 centimeters, right? To find the diameter of Earth, and we do this because it gives depth to the exercise. It's no good just using 2 points, because it's kind of not enough to get a good feel about what's going on. So we obviously include Earth and its diameter. It gives the whole thing depth. Things start to make sense. So to find the diameter of Earth, what we do is we divide the Sun's diameter by 109. Okay, I'll show you why we do that in a minute. So we divide 3mm by 109, we get 0.027 millimeters. That's 27 micrometers. There are 1,000 micrometers in a millimeter, okay? I then go on, this is 5 centimeter, because this is what I do here. I then go on to use a 5 centimeter bulb, because 5 millimeter, because 3mm is too small. And we would have ended up clumped up with a lot of planets right here, right? A bit cramped. So now there's a couple of things that we need to know here. If you're going to toy around with Earth, distance, and the Sun, you know, you want to get a feel for it, there are a few constants that you can think of. One of those constants is the distance between Earth and the Sun. It's always going to be 108 sun diameters. The reason for that is the distance between Earth and the Sun is 150 million kilometers. So if we divide that distance by the diameter of the Sun, we get 108. So any time you're ever doing a diagram of something, right, and you've got a certain size Sun, you know for a fact that 108 of those suns is going to be bang on the distance to scale that Earth is away from that Sun. All right. So if you've got a dime or a nickel or anything, right, you get the measurements of that nickel, the diameter, and you multiply it by 108, and that is how far Earth would be. The second constant, Earth's diameter in this exercise, right, is always going to be the sun's diameter divided by 109. The reason for that is if we divide the sun's diameter by Earth's diameter, we get 109. There are 109 Earth diameters in the sun's diameter. So to get Earth's diameter, all we have to ever do is divide the sun's diameter by 109. It doesn't matter what size diameter you're using for the sun. If you divide it by 109, you will get a very accurate measurement for the Earth's diameter, all right? And the other one, which is very important, the sun will always radiate light at a rate of 1 diameter every 4.6 seconds. Now, you know this, right? And this is the thing that jumped out at me a couple of years ago, right? Nobody told me about this. I spotted this on my own, and I looked at it and could not believe what I was seeing. If we divide the sun's diameter by the speed of light, we get the number 4.6, and that is seconds. That means because the sun, its diameter is 1,390,000 kilometers, and the speed of light only travels at 299,792 kilometers per second, what we have is an irregularity. And this is the irregularity that I have been screaming about, right? Because that's 1, 2, 3. Oh look, I've done it, I'm out, right? Let me do that again because it's important, right? I'm way off the mark there. What we have is a sun whose diameter is way bigger than the speed of light travels in 1 second. Right? So let's go again. So we've got about there. 1, 2, 3. All right, we'll go there. All right, 4. So this, from there to there, it's 299,792 kilometers. So that means it's going to take 1 second for the light to travel from there to there. And then we've got another one, and another one, and another one, and then we've got a 0.6 of a second. So it's 1 second, 2 seconds, 3 seconds, 4 seconds, and a 0.6, which equals 4.6 seconds. Now the problem we're having here is when we bring this down to scale in a diagram that we want to see how things work, right? So what I do, I bring down the actual distances and sizes to a workable size so that we can look and see what's happening. Now, when we bring the sun down to a 5mm bulb, right, which is what we're going to look at here now. So this sun is a 5mm bulb. To find the distance of Earth from the sun, we multiply by 108 because there are 108 sun diameters between Earth and the sun. So 108 times 5mm is 54 centimeters, okay? So the distance between the sun and Earth is 54. 5 millimeters divided by 109 equals 0.0459 millimeters. That's 45 micrometers, okay? There are 1,000 micrometers in a millimeter. So Earth is like just under a 20th of the size of a millimeter. You wouldn't see it, okay? It's almost invisible. But this right here is where they are to scale right now, right? So I want to bring a working diagram, something I can see and work with, okay? So let me just close this a bit. Now, what we have here, this is to scale, okay? We've got the sun, right? Let's get a bit closer. We've got a sun. It's a 5 millimeter bulb, okay? There. We've got Mercury, and Mercury, these are all to scale, okay? Mercury was at a distance of 69 million kilometers from the sun. So what I did, I divided 69 million by 1,390,000. That's the sun's diameter. And I got, I think it was 49. I then multiply the 49 by 5 millimeters, right? Because that is the diameter of the sun. And I think we got 24.5, right? And then I did the same with Venus, and we ended up with 39 or something. And then the same with Earth, and we know that's up there, it's 54. So there is 54 centimeters between this sun of 5 millimeters and this Earth, right? These are perfectly to scale distance-wise. They're not size-wise. I've added the actual planets so we can see where they are, because they would be tiny. Earth would be the 20th of a millimeter, so it's like a speck of dust. Mars would be tiny as well. The first time we get a proper indication of size is when we go out to Jupiter. It's there, right? In the middle there, the doorway. So now this is where the trouble starts. This is where the trouble starts. We have got ourselves here a perfectly to scale sun and distance to Earth. It's perfectly to scale. The sun is actually 1,390,000 kilometers wide. I've brought it all the way back down to 5 millimeters. Everything else is shrunk with it. The distance between the Earth and the sun is usually 150 million kilometers, but I've reduced it down the same ratio as I have this sun. So 150 million kilometers becomes 54 centimeters. It's perfectly to scale, okay? Perfectly to scale. So, what should happen when I turn this bulb on? This is where the problem is, right? It's a paradox. And right here, this is where the issue is, right? This bulb, when I turn it on, if it behaved like the sun does up there, it will take 8 minutes and 20 seconds for it to travel from here to planet Earth, right? If this sun behaves like it does up there, it's going to take 4.6 seconds to radiate its light the distance of each of its diameters. That's what they're telling us our sun does. And I'm saying no. I'm saying it doesn't. I'm saying that the light from that star cannot be measured. It's absolute. It's too fast, right? It's obvious. Now I'll show you what happens when we turn the bulb on. Now we would expect, this is a to scale, perfectly to scale diagram, distance between the sun and planet Earth. We've got Mercury and Venus in between for depth, but they do nothing else. Right. So what we have, we're about to turn the sun on. They tell us it takes 8 minutes and 20 seconds for the sunlight to reach planet Earth. It travels 150 million kilometers in 8 minutes and 20 seconds. That works out to be 299,792 kilometers per second. Now this is what happens when I turn this bulb on. Right, ready? Now, it's far from 8 minutes and 20 seconds. So of course the screams will come. Well, yeah, because it's a bulb, it's small, and the distance, of course it's gonna, no. This is to scale, right? The sun is down to 5 millimeters in diameter, right? It should take that sun 4.6 seconds to radiate light the distance of its diameter. It should take that sun 3 minutes for its light to get to Mercury, and then another 3 minutes 20 to get to Venus, and another 2 minutes to get to planet Earth. That's 8:20, but it's instant. Yeah, well, of course it's instant because it's a bulb, and no. And, okay, right, so if we want to get a proper working diagram at this scale, all we have to do is go and source a bulb that radiates its light like this. Now, can you see the problem? There isn't a bulb that radiates its light that slowly, is there? To scale, right? To scale, this bulb should take 8 minutes and 20 seconds for its light to reach there, because this is a perfectly to scale diagram. I've shrunk everything down, but the properties of everything should remain the same. But it's impossible for them to remain the same because that light is too slow. There isn't anything in existence that takes 4.6 seconds to radiate its light the distance of its own diameter. So here is the paradox. What is what? If we cannot find a source, right, this is common sense now, that takes 4.6 seconds to radiate its light the distance of its diameter, why are we believing that the sun, the size and power of it, right, would take 4.6 seconds to radiate light the distance of its diameter? This bulb, look at it. Compared to the sun, if the sun were brought down to 5 millimeters and it behaves exactly like it does up there, it's got nothing on this bulb, right? We'd turn the sun on and we would literally watch it go radiate its light like in slow motion, like in a movie, because it takes 4.6 seconds per diameter, right? So this right here is a problem. It's illogical to think that anything in existence can take 4.6 seconds to radiate light the distance of its diameter. Yet we've been led to believe that the sun does that, right? When in fact, if you look at this bulb and you blew this bulb up to a diameter of 1,390,000 kilometers, what would the light do from the sun? What would it do? I'll tell you what it would do. When it's switched on, it lights up the entire solar system like that, because it's fairly obvious to see that light is absolute, right? This small to scale diagram proves that. But now we've got the common sense issue. They are telling us one thing, and some of us, or me, is saying something else. So I am swimming against the tide, right? I know for a fact that Roma could not have observed Io coming out from behind Jupiter in the 1600s. I fully understand that Fizeau had no chance whatsoever of sending a light beam 8 kilometers, having it bounce off of a mirror, and then come back another 8 kilometers and land onto the teeth of a spinning wheel before electricity. It's impossible. That's another one. There isn't a calculation anywhere that proves the speed of light from the sun has been worked out. That's number 3. You've got the sun in the sky, right? You can see it and feel the heat, right? There's no delay. That's number 4. Just pure common sense. That should be number 5. And it can go on. All the experiments. James Bradley discovering stellar aberration in 1728. With what? You don't just go out into the garden one night and look up and go, I think that star's moved over a little bit in there. I call it stellar aberration. These things, when they're looked at closely and carefully, they are absurdities. But what's happened, the majority of the population have been fed rubbish, right? Not in detail, just, yeah, he did that in 1700s. He did that in the 1800s. He did that in the 1900s. And everybody has believed everything, right? But now, looking back, right, and trying to find one single calculation, right, that ties in with the speed of light, how it was worked out with the numbers, showing you exactly what they did, there isn't one. Right, now my common sense, I know what's going on. And then now we have the second part of this. People like me who can see through the BS, and we go to these tiny details. The 2-scale diagram, knowing that it's impossible, we see the ins and outs. We bring things down to 2 millimeters, 5 millimeters. We work out the intrinsic details, right? The small details, right? And we can see. But unfortunately, these details are beyond what your average population can work out. And on top of that, your average population has been told people like me are conspiracy theorists. So there is no way I'm going to convince any of the general population that this is right? Because they do not have the intelligence to work these things out. When we get to this scale of things, people rely on other people to tell them. I was talking to some person yesterday, she's bagging me, right? But she didn't know arse from her elbow. But her whole attitude was, well, if I read about you in a peer-reviewed magazine, in a reputable source, then I'll know that I was wrong and I'll apologize to you. So she hasn't got a clue, no common sense. She relies on publications that have already been peer-reviewed, right? I'm not gonna ever be peer-reviewed. I am at the source, right? I'm sorting these things out at the source. And I know for a fact that the light radiating from the sun cannot be measured. I know for a fact that the light radiating from the sun is absolute, right? This is just the perfect way to prove it. But to understand that, there needs to be a certain amount of trust in your own judgment, right? And this is where the battle is at, right? There is no working out of the speed of light anywhere. There is not a set of numbers that proves that light travels at 299,792,458 meters per second. Now, with a specific number like that, and it is a specific number, where is the specific equation that worked it out? there isn't one, right? Everybody just presumes. So this is a dilemma. Us conspiracy theorists do see between the lines, but the general population won't ever believe us because one, they've been told we're full of it, and two, they don't have enough knowledge and intelligence to come down to where these things are being worked out. It's beyond them, right? That is the divide. That is the divide. We know and we can see these things and we scream about them, but the majority aren't intelligent enough to understand what we're screaming about. So when they see our workings out, they look at it and go, what is this all about? And they call us an idiot, right? Come back when you've been peer reviewed, right? That is one of their biggest weapons. They've classed us conspiracy theorists as fruitcakes, but we're not. We are the ones that see through the BS. That's why our content is getting slowed down. That's why they're trying to keep us quiet, all right? Now, you think maybe that 4.6 seconds to radiate light, the distance of its diameter, even for the average person, right? You're probably thinking, well, that is a bit strange, isn't it? That is a little bit strange. Now, let me show you something else before we knock off. At the diameter of 1,390,000 kilometers, right? At the speed of light, the sun takes 4.6 seconds to radiate light the distance of its own diameter. It is strange. It doesn't matter where you're from or what level of education you have. Surely you must understand that for something to radiate light that slowly, something that powerful, right? Don't you think a question needs to be asked, or you just accept it, right? What we have here is UY Scuti. It's one of the biggest stars ever discovered. It has a diameter of 2,377,000,000 kilometers, right? If we divide this UY Scuti's diameter by the sun's diameter, 1,710 suns fit inside Scuti's diameter. If we divide Scuti's diameter by the speed of light, we get 7,928 seconds. When we divided our sun by the speed of light, we get 4.6 seconds. When we divide Scuti by the speed of light, we get 7,928 seconds. Big exercise. Let's divide it by 60. We get 132 minutes. Let's go down another one. That equals 2 hours and 12 minutes for UY Scuti to radiate its light the distance of one of its diameters. Now, if I did a working scale diagram, including UY Scuti, that sun, if I brought UY Scuti down to the size of that bulb, and I wanted to watch it radiate its light, the distance of that bulb, I'd be sat there for 2.5 hours waiting for this monster to radiate light the distance of one of its diameters. So what we're saying is, we've got a ball, right? This is the sun. This is UY Scuti, right? It comes out to here and it goes back 3 dimensions. So this is the front of it. If I move back 1 diameter of UY Scuti, I'm being told with the speed of light, it's going to take 2 hours and 12 minutes for this monster to radiate its light, one of its diameters. Now, can you see where we're at? 2 hours and 12 minutes, or that way. And 2 hours and 12 minutes to radiate its light from there, that way, one diameter. If we put planet Earth's in Scooty's diameter, there's 186,390 planet Earth diameters in UY Scooty. It is a monster. I repeat, the light radiating from the stars and from our sun, it's absolute. It is a slam dunk. These claims of all of these stars and suns not being able to radiate their light instantly is an insult to people's intelligence, right? Now, I know I'm one of the few people that is stuck in between what is taught and the truth. But I stand by this, right? I stand by this as long as I need to. Why is it that there is no calculation anywhere that proves that they've measured the speed radiating from the sun, the speed of light radiating from the sun? Where is the calculation, people? Don't you get it? But that's not enough. You people still believe without the calculation, right? You believe Roma did the impossible. You believe Bradley did the impossible. You believe that Fitzo launched a light beam 8 kilometers one way, it bounced off of a mirror, come back, and then landed on the teeth of a spinning wheel. Before electricity. I could go on and on and on. But you've been programmed to believe that us conspiracy theorists are mental cases. We are not, right? I stand by what I say. 2 hours and 12 minutes to radiate its light the distance of one of its diameters. People, they have you living in the twilight zone. 32 minutes. Okay. All right, peeps. See you later.